Hey, what is going on, guys, and welcome back. And in this video, we're starting section 3 of part 5. We're going to be learning about the dictionary data type in Python. If you have some programming experience, perhaps with JavaScript in particular, or even TypeScript, dictionaries in Python will look very similar to objects in JavaScript and TypeScript. They behave similarly, they hold key value pairs pretty similarly, and you can have the same functionality in them as you did with, or not functionality, but the way you can access data out of dictionaries is pretty similar to how you can do it in JavaScript and TypeScript. So if you have that kind of experience, you'll find this topic to be pretty easy to digest. And as always, if we go through any information that I think is worth diving a little bit deeper into, I will do just that. I will run some code through the Python playground, visualizer as well. We'll go into the Python playground like we always do to explore some of the examples that they provide for us a little bit more in detail. So yeah, there's 9 exercises in this section. I have them all opened up and loaded in VS Code, but in this video in particular, I will try to get up to uh, the second phone book exercise, um, and then we'll see how far we get along. We've gotten along up until this point. I mean, how far in the video we are. If we're in the 40-minute range, then I will definitely stop there, and then in the next video we'll finish the rest. But if we have some time to spare and I'm still feel like I'm in good condition to continue, then we'll do the rest of the material for this section in the same video. So the learning objectives are that after this section, you'll be familiar with the dictionary data structure. You'll be able to use a dictionary with different types of keys and values, and we'll learn about key value pairs. And you will know how to traverse through the contents of a dictionary. And you will be able to name some typical use cases for dictionaries, which will be pretty awesome. And once you know this kind of stuff, when you start writing your own programs in the future, having the knowledge of all of these different data types, not just your primitive data types like integers and strings and floating point numbers and whatnot and booleans, right? Knowing dictionaries, you're going to be able to come across a scenario where having a dictionary or creating one will be very useful to get your program to do what you want it to do. We already know about lists, so these are some of the, I shouldn't say better or more important per se, but some of the higher level data types in Python in particular that can really push your scripts and your programs up to the next level. So let's get started. Lists can be handy in many situations, but they are limited by the fact that the items are accessed through indexes 0, 1, 2, and so forth. If you want to find some item in a list, you will either have to know its index or at worst, traverse through the entire list. Now, this could be a problem, right, if you have a really, really huge list, right? If you have a list of like 10 items, then this isn't going to cost you that much time. But if you have a really, really huge list, for example, if you have like a list that contains users in a database, for example, and you have like 1,000,000 users, right? So in order to find a specific user, then you're going to have to traverse through the entire list. And worst case scenario in that instance, as we've talked about in previous videos, is if that user that you're looking for happens to be the last person in the list or like somewhere towards the end of the list. So you're going to have to sit through several 100,000 iterations or traversals to get to that specific value. So this is where dictionaries come in handy. Another central data structure in Python is the dictionary. In a dictionary, the items are indexed by keys. Each key maps to a value. The value stored in the dictionary can be accessed and changed using the key. So this is where now instead of, say for example, instead of having a list that contains usernames, now you have a dictionary that contains usernames. And so you can traverse that dictionary using the some keyword, right? Like the username, for example, of a specific user. So you can go through the dictionary and say, hey, dictionary, find the user Steve. And the dictionary will be able to find what Steve points to in the dictionary a lot faster than you would have to if you were traversing a list. Using a dictionary. The following example shows you how the dictionary data structure works. Here is a simple dictionary from Finnish to English. we declare a variable called my dictionary, or I should say my underscore dictionary, and it's assigned this empty thing. It has an opening and closing curly brace, and there's no content between the curly braces. Now, when we do my dictionary, then we use square brackets and pass the string apina, set that equal to monkey, and then we do that several times for another string called banani for banana, and cimbalo or kimbalo for harpsichord. Then when we print the length of the dictionary, now dictionary has 3 items. And when we pass my dictionary to the print function, now it prints our dictionary with the keys, right, and their values. So you can see these colon separated. So the key comes with quotes and it's a string, and then the value comes with quotes and it's a string. Now don't let this fool you. You can also have different data types as well, but this is just an example using strings. And then we can access specific values um, from our dictionary using specific keys. So we can access them using bracket notation like this. So when we say my dictionary apina, it returns monkey, right? Because apina is paired with the value monkey. The key name apina is paired to the value of monkey. So I'm going to put this in the Python playground just for us so we can see. So first, let's print just what my dictionary has before we start adding items to it. So you can see. So when we first log the empty dictionary, right, it's empty. And if we do the same thing with the length, you can see that it has a length of 0 because there are no items in it. Then to add items to our dictionary, in fact, let's do this. My dictionary, right, because we're using Finnish and English words. Let's just use plain English. It might be a little bit easier to follow. So when we do print length of my dictionary, we expect it to print 0, right? Because our dictionary is currently empty. There's nothing in there. And in fact, if I just pass the dictionary name, right, we get this empty object, right? This empty data that has opening and curly braces and no content within it. Now I want to add uh, uh, content to our dictionary. So when I say dictionary, so for example, user1, and I'll set that equal to Steve. And then we can do user2, and that could be Mark. And user3, that could be Dylan, right? Now when I log the dictionary and its length, you'll see that's going to have something completely different. Right now we have user1 points to Steve, user2 points to Mark, user3 points to Dylan, and all of these keys and values are encompassed or wrapped in our opening and closing curly braces. And the length of the dictionary is now 3, right? Because we've added 3 key values into our dictionary. So if I wanted to say I wanted to get user3, right? Maybe somebody else wrote this dictionary, but we don't, and the only thing they told us is how they structured the names of the keys for each item in our dictionary, but we don't know what the values are. So I wanted to get the value for user2. So I can do print, and I'll say user2, then I could do my dictionary and pass user2. What am I missing here? Oh, right, because I need to escape this. Oh, can you even escape in F strings? So let's do it. Let's do a regular like that. There we go. So now user2 is Mark, just like that. Now you're probably wondering, well, is there a way for us to, given the value, find what key it's paired to? And there is a way. I might talk about. If you guys want to learn, you're gonna have to use loops to do that. You can try to explore that on your own, and then let me know in the comments below if you figured it out. But if not, I will make a video and talk about that just a little bit. But dictionaries are typically the way that they're designed is to be able to look up values based on given keys, not the other way around. But there is a way, if you're curious, to get the key given a specific value. Okay, so that's the basic gist of how dictionaries are work in Python. The bracket notation creates an empty dictionary to which we can now add content. 3 key value pairs are added. Apina maps to monkey, banani maps to banana, and banana, I say banana. I feel like a minion. And cembalo or cembalo maps to a harpsichord. Finally, the number of key value pairs in the dictionary is printed along with the entire dictionary and the value mapped to the key apina. After defining the dictionary, we could also use it with user input. So here we declare, it's just how we've been getting user inputs in Python from the very beginning, right? This is nothing new. We've seen this format before, right? We have a variable called word, which is assigned the input that is stored from prompting the user to type in a word. Then we say if word is in my dictionary, print the translation, right? So in other words, if we have the key, then print what it maps to, right? Otherwise, print word not found. Again, we can do it like this here. Like say word is equal to input. Please input a username like that. And then we can say if word in my dictionary, print what did they write here? Print username word and my dictionary word like that. Else print username not found. So here, if we write user1, username user1 is Steve, right? We can format this a little bit better. We can add uh, 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 quotes and whatnot to wrap the username in, and we can also wrap the return key in quotes if we want to format this a little bit better. But that's basically the gist of it, right? We can also use inputs to find what keys are mapped to in our dictionary. Notice the use of the in operator above in our if statement here. When used on a variable of type dictionary, it checks whether the first operand is among the keys stored in the dictionary. So this is checking if our word is among the keys in our dictionary, right? So this is everything saying if key is in dictionary, then do this, else print word not found. Given different inputs, this program might print out the following, right? Please type in a word, and we'll type in apina, then translation, monkey. Please type in a word pollo or polo, word not found, right? Because this key isn't in our dictionary yet. All right, now this is what I was talking about earlier. What kind of values we can store in dictionaries. The data type is called dictionary, but it does not have to contain only strings. For example, in the following dictionary, the keys are strings, but the values are integers, right? So we can have this dictionary called results, and then the key Mary that we're adding to our results dictionary points to the integer 4. The key Alice points to the integer 5. The key Larry is mapped to the integer 2, right? Here the keys are integers and the values are lists, right? We can also have integers as keys in dictionaries. So we have this lists dictionary. We add this key of integer 5, and it points to this. It's mapped to this list, right? The list of 1, 2, 3. We have another here key, integers 42, and it maps this list, and so on and so forth. So you can have different types of data types as keys in our dictionaries. You're not limited to just strings. How keys and values work. Each key can appear only once in the dictionary. If you add an entry using a key that already exists in the dictionary, the original value mapped to that key is replaced with a new value. So when we create our dictionary, right, my dictionary, and we are trying to add this key suri and mapping it to this string big, right, the value big, and then we do it again, map it to large, when we try to print what the key suri is mapped to, it's going to print large because we're overriding it here, right? We set it the first time to point to big. Then we overwrite that and we set it to map to large. So now in our dictionary, this key suri is mapped to the value large. All keys in a dictionary must be immutable, so a list cannot be used as a key because it can be changed. For example, executing the following code causes an error. So if we have a dictionary here and the a key that we're trying to add is a list, and then we're mapping it to the integer 5, we get a type error, unhashable type list, right? Because we can mutate the contents of a list, right? But our keys cannot be, should be immutable, right? We shouldn't be able to go back in and change them once we set them. Notice the word unhashable in the error message above. This is a reference to the inner workings of the dictionary data type. Python stores the content of a dictionary in a hash table. All right, we'll learn about hash tables in the future. Each key is reduced to a hash value, which determines where the key is stored in computer memory. The error message above indicates that a list cannot be processed into a hash value, so it cannot be used as a key in a dictionary. The data structures and algorithms courses will further explore hash tables. So this will be in the advanced course. So we might not learn about hash tables in any of these remaining chapters. Okay. Unlike keys, the value stored in a dictionary can change, so any type of data is acceptable as a value. A value can also be mapped to more than one key in the same dictionary. Okay. And this right here is just saying that we can have user 1 and user 2, or I should say maybe user 2 has a mark and user 4 also points to mark, like this, right? We can have two keys that point to the same data. Okay, so now we have our first exercise. And again, this is we've covered this which is what they were talking about here, right? We can overwrite what our values are from our key name, right? Once a key is set in the dictionary, we can't overwrite it. We can't go back and say, hey, Suri now is, instead of Suri with one eye, is Suri with two eyes, right? That's going to the dictionary. When you do that, the dictionary is going to say, hey, this is a new key that we're adding to the dictionary. It's not, we're not updating an existing one. We can only update what value that the key is being mapped to. We can't update the actual key name itself, right? So this is what this section is saying. Okay. First exercise called times 10. It says, please write a function named times 10. I'm just going to copy this, which creates and returns a new dictionary. The keys of the dictionary should be the numbers between start index and end index inclusive. The value mapped to each key should be the key times 10. For example, when we declare a variable here d, set that equal to a function times 10, give it the start and ending index, and then print d. It should print a dictionary where the keys are start from our given start number and end from our given end number, and the values that each key is mapped to is times 10 the value of the key. So if our key is 3, then the value should be 3 times 10. If our key is 4, then our value is 4 times 10. So that's how you get 30, 40, 50, 60 mapped to 3, 4, 5, 6. Okay, so that sounds pretty straightforward. Let's open up VS Code. Open up our code here. And all right, we're going to define the function. And this should be pretty straightforward. What we're going to do here is create a dictionary. Set that equal to I think this might be a reserved keyword. But let's just continue. We're going to use a for loop. We're going to say for I in range, start index, end index, pardon me, I misspelled range here. Then we're just going to say dictionary at I is equal to I times 10. Then we're going to return the dictionary, just like that. Now we just want to test this. If name is equal to main, like that, D is equal to times 10, 3 to 6, and then we want to print D. So let's run this and see what happens. I already know what's going to happen, and we'll talk about that in a second. So you can see it does pretty much what we expect it to do. When we print a D, it starts, the first key is integer 3, and it's mapped to the value 30, followed by integer 4 as the key name, mapped to the value 40. I mean 30, then 40. Then integer 5 mapped to the key 50. But we don't have integer 6, right? If you see from our example here, it should also include our ending index inclusively. But if you remember, when you're working with ranges, the end index, it will loop for every value up to, but not including the end index. So to include our end index, we're just going to do +1 here. So now when we run this, we get 6 mapped to 60 also added to our dictionary. So that's it. Now, they're not interested in this, so we can just do that and submit the code. We can run our tests. And there we go. We can send that solution to the server and open the model solution in the browser. And there we go. They did the same thing. They created a dictionary here called numbers. Then they added each key as the current index in our loop. And the value mapped to it is that index times 10, and then we return numbers. In fact, I like the dictionary name being numbers, so we'll just use that as well. And if you like, you can just submit the test again. It'll submit that second solution, right? And that's that. So that was pretty easy and pretty straightforward. Refresh it, make sure we got credit for it, and we did. Now here we have another exercise called factorials. And in this exercise, we're being asked to please write a function named factorials that take in a value n, which is an integer. It returns the factorials of the numbers 1 to n in a dictionary. The number is the key, and the factorial of the number is the value mapped to it. A reminder, the factorial of the number n is written with n with the exclamation point and is calculated by multiplying the number by each integer smaller than itself. For example, the factorial of 4 is 4 times 3 times 2 times 1, and so that equals 24. An example of the function in action. So here, k is equal to factorials, and we pass the number 5. When we print k1, it prints 1. k3, it prints 6, and k5 prints 120. Okay, so I'm just going to close all of this, collapse that folder, open this one. Here we're going to define a function called factorials, which takes in an integer. We're going to create a dictionary here called numbers again, and we're going to use an helper variable called result, set that equal to 1. Then we're going to start looping. We're going to say for I in range of n, then result is equal to times equals I, and then numbers at I is equal to result, and then we're going to return numbers. Now let's test this. If name is equal to main, then we're going to do k is equal to factorials 5, print k1. We're just going to do all values up to 5, and then 5 like that. Let's run this and see what happens. Okay, we get 0, 0, 0, 0. Maybe what, n plus 1? Okay, so that got rid of our error, but we're still getting a problem here. Okay, so the issue here is because we didn't give it a start number, right? This needs to start at 1 because if we don't supply a start number, then it starts counting from 0. But we need to give it a starting number of 1, so because the factorial of 1 is 1, right? If we had factorial of 0, then we'll never have any value, because it'll always be 0 times whatever integer that we are, which is always going to return 0. So that's why we're always getting 0, 0. So let's run this now, and there we go. We get 1, 2, 6, 24, and 120. Now we're only concerned about these 3 values, so we can do that. We should see 1, 6, and 120, and there we go. Now, if you're wondering how this is basically working, imagine if we were to do like a list like this. So factorial of 1 is 1. Then when in fact, we should put this up here, right? So first it starts with the value 1. So what it's doing is result, which is also set to 1. 1 times equals 1. So when I is 1, so it would be 1 times 1 basically. So we add 1 to our factorial list. And I'm just using a list here as an example. Or we should just actually do the dictionary. So the first key will be 1, like that. And the result, right, the value paired to it will also be 1, because we do result is 1, I is 1, 1 times 1 is 1. Then I becomes 2. I becomes 2. So now we do result, which still has the value 1. Then we do 1 times equals 2. Well, what is 1 times equals 2? And that's 2. So the key 2, right, when I is 2, which is now our new key, it's mapped to the value of 2. Now I becomes 3. So the result is 2. So what is 2 times equals 3? That gives us 6. So with our key value 3, the value is now 6. I becomes 4, and then you get the gist. So now it will be 6 times equals 4, which is 24. And then 5, okay, what is 24 times 5? And that's 120. So another way to think of this isn't doing, for example, let's say we want to get a factorial of 5. It's not doing 5 times 4 times 3 times 2 times 1 in this case in our dictionary, but instead it's saying, hey, do 5, right, whatever our current index is, multiply it by whatever is stored in the previous dictionary. So instead of doing 5 times 4 times 3 times 2 times 1, do 5 times 24. And that's how we get the next number, right? We get the next value. So hopefully that makes it clear for you to see of what's going on here. But yeah, so that's it. We're not worried about this, so we can just submit our solution. There we go. Send that solution to the server. And we can open the model solution in the browser as well. And there we go. They did the exact same thing that we did. They did a result, dictionary called result, and a result at the first position. They set that equal to 1. We didn't do that, but you can because we know factorials, right? The first, right, factorial of 1 is 1. So we can set the first item, the first key in our dictionary, and map that to the value of 1. And then start our loop here, but instead of starting from 1, start it from 2, and then do n plus 1, right, to make sure that it's inclusive to the end. Now the result at index 2 and onwards will be result at I minus 1 times I. And then set that, and then return the result. So you can do it like this, and you can do it like this. I think this might be even just a little bit easier to follow. In fact, here we can do is equal to result times I. If you want to do it this way, but for sake of simplicity, you do it that way. So that's the solution for this exercise. So I'm going to close all of these, and we can keep going to the next readings. All right, traversing a dictionary. The familiar 4-item in collection loop can be used to traverse a dictionary too. When used on the dictionary directly, the loop goes to the keys stored in the dictionary, one by one. In the following example, all keys and values stored in the dictionary are printed out. So we have a dictionary here called My Dictionary. We add the values, and then we loop through the dictionary like this. So we can print the key and then print the value. So if we go back here to our dictionary that we wrote, right, we just do for users in My Dictionary like that. Print not users, for user, print username user, and then print username. Now we have user one, and it points to Steve. User two points to Mark. User three points to Dylan, and user four points to Mark. Right, or maybe we can just do the same thing, key and value. There we go. Right, so now here we have our key username one, value is Steve. Key username two, value is Mark. Key username three, value is Dylan, and key username four is also Mark. Sometimes you need to traverse the entire contents of a dictionary. The method items returns all the keys and values stored in the dictionary one pair at a time. So for key, comma, value in my dictionary.items, then we can do it this way. So if we don't want to do it this way, we can say for user name value in my dictionary.items, print. Right, we can just do key, so that to username, and print value, so that to value. And they do the same thing. Do the exact same thing. In the example above, you may have noticed that the keys are processed in the same order as the key were added to the dictionary. As the keys are processed based on a hash value, the order should not usually matter in applications. In fact, in many older versions of Python, the order is not guaranteed to follow the time of insertion. Some more advanced ways to use dictionaries. Let's have a look at a word of lists. A list of words. Right, word list here, variable points to this list, which contains banana, milk, beer, cheese, sour milk, juice, sausage, tomato, just a mishmash of different foods and beverages. We would like to analyze this list of words in different ways. For instance, we would like to know how many times each word appears in the list. A dictionary can be a useful tool in managing this kind of information. In the example below, we go through the items in the list one by one, using the words in the list as keys in a new dictionary. The value mapped to each key is the number of times the word has appeared. So here we define a function called counts, which takes in a list. Then we create a dictionary of words. So for word in my list, if the word is not yet in the dictionary, initialize the value to 0. If word not in words, words at that word so that equal to 0. Then increment the value, words increment by 1. So now we can see how many times banana shows up. Once. How many times milk shows up? Once. How many times does beer show up? 3 times. Cheese shows up twice. Sour milk shows up 3 times, right? And we make sure that remember, we can never have 2 keys that are the same, right? Because essentially what you're going to be doing is overriding it. So this also ensures that each key is only entered once into our dictionary. So this is a way that we can map and see how many times something shows up. What if we wanted to categorize the words based on the initial letter in each word? One way to accomplish this would be to use dictionaries. We define a function here called categorize by initial, which takes in a list. We define this dictionary called groups, and then for word in my list, initial is equal to word as 0. If initial not in groups, groups at initial set that equal to an empty list. Add the word to the appropriate list. Groups initials that append a word, and then return groups. And then when we print words beginning with B, it prints banana, beer, butter, beer, butter, beer. Words beginning with M, milk, margarine. Words beginning with C, cheese, cucumber, cheese, chocolate, etc., etc. All right, so hopefully this part made sense. If you want me to talk a little bit more about this, let me know. But you should. But what we just learned here will be useful for doing this exercise called histogram. says please write a function named histogram which takes a string as its argument. The function should print out a histogram representing the number of times each letter occurs in the string. Each occurrence of a letter should be represented by a star on the specific line for that letter. For example, the function called histogram, ABBA, should print out A shows up twice and B shows up twice. While histogram statistically should print out STAICLY, and then we see that S shows up twice, T shows up 3 times, A shows up twice, I twice, C once, L once twice, and Y once. Okay. Okay, let's open the file here. We're going to define a function called histogram, which takes in a string. We're going to open an empty dictionary here. Then we're going to say for character in my string, if character not in letters, then letters character is equal to 1, else letters at character plus equals 1. Now, this should work, but we need to print out this. So we need to loop again. We're going to say for a letter in letters, print letter followed by the asterisk, I think, like that. Now we can do if name is equal to main. Then we can just call histogram, pass ABA, and then pass statistically. See what happens. Okay, so we do, let me hide this. So we do get A with 2 asterisks and B with 2 asterisks. Now let's try statistically. Did I spell that right? Statistically. Yeah, I did. Okay. And now we get STAICLY, right? We don't get duplicate letters because it's impossible to have more than one letter show up, because otherwise it will overwrite this. So T only shows up once. Is logged once, but it shows up 3 times in the word statistically, right? We have 1 T here, 2nd T here, 3rd T here. Same thing with S. S shows up S here and S here. A shows up twice here and here. I shows up twice here and here. C shows up once here. L shows up twice at the end, and Y shows up once at the end. So now we know that our function works. So again, they don't care about this in the solution. They only worry about this. So we can just submit our tests. We pass, send that solution to the server. And then we can open the solution, model solution in the browser as well to see what they did. And they did basically the exact same thing. 2 loops, one to add the characters to the characters dictionary, and then another one to loop and print out the stars. And they calculated the stars here independently. We did it in here, but both pieces of code do the same thing. They did this format as well. So for character and I'm assuming how many this will be for how many times that character shows up in characters and items, right? Then the value, right? So now they do stars times equals the value, and then print character and stars. So yeah, awesome. So that's the solution to that. Go back to the browser, refresh, and it worked. Here we have the phone book version 1. It says please start a phone book application. It should work as follows. Prompt the user to enter command 1 search, 2 adds, and 3 quits. If you type in 2, then it lets you add a name and a number to the dictionary, and then it prints out OK. If you enter 1, you can look for Peter, and it returns the value. And then, right, you can do search multiple times, and if you enter 3, it prints out quitting, and then it quits. So this should be pretty straightforward, I think. Feels very familiar to some of the older exercises that we did. So we're going to use a while true loop. Then we're going to say option is equal to input command. Oops, excuse me. In fact, I'm just going to copy this like that. Then we're going to say if option is equal to 3 quit, then break. Then we're going to say if option 1 search, I'm sorry, just 1. Then we're going to factor, we're going to have phone book dictionary. We're going to say for person in phone book. Actually, no, we're going to need to prompt them for the name. Name is equal to input name. Then if name in phone book, print phone book name. So it's going to print number like that. And then print OK. Actually, print quitting. And then kick us out of the loop if option is 1. Now it doesn't say, oh, it does say, else print no number. Okay, and then if option is 2, then we need to prompt it for the name and the number. Name is equal to input name. Number is equal to input number. Then phone book name is equal to number. Now, OK needs to be printed for either option 1 or 2. So we'll have to make that outside like that. I think this should work. So let's run this. Okay, so if we say search and we type in Peter, it says no number. Okay, so OK only shows up for these 2. So then I need to move this up. So let's run this again. In fact, actually, let me clear. Okay, so now if we run 1 and we write Peter, no number. If we do 2 and we type in Emily and her number is 045 121 2344. Okay, now if we look up Emily, we get her number and then OK printed. Okay, if we add Peter, Peter's number is 040 5466 745. Let's add, okay, let's look for Mary. It says no number. Okay, so now when we do 3 for quitting, it prints quitting and then it exits out. So I think this should be the solution. Let's send that. Okay, we failed. Instead of 3 rows, the program prints out 4 rows. With input 2, add Mary, then look out for Mary. Expect the printout is OK. 040. Oh, wait, what? That makes no sense. If we add Mary, then we'll look up Mary. Expected printout is okay. Let's test this one more time. It's Python phone book version 1.py. Where am I? Oh, CD into source. Sorry. Okay, Python phone book version 1.py. Okay, so they say with the input. So if we add Mary 040234567, then we'll look for Mary. And then we quit. What's the problem? Did I spell quitting wrong? Nope, I didn't spell quitting wrong. Because this is weird. So when here, the first input, they enter 2. Then they enter the name and the number, and it prints out OK. So same thing we did here. We enter 2, we type in the name, the number, and then it prints out OK. Then they added Emily, also prints out OK. Then when they look up Peter, it prints out Peter's number. Oh, I see the problem. Okay, so, okay, I see the problem. This is the problem, right here. Pardon me. Oh, still failed. I thought the problem was because we were printing the number. Okay, 040, and then quitting. Right, so if we run this again, right, we want to add Mary, her number is 040234567. Then we want to look for Mary, and then we want to quit. Prints OK. Oh, I see. So this, I think that should have been the problem. There we go. So I got confused here. Right, when you look up, you don't print OK. You only print OK when you add a new user, when you add a new person to the phone book. But when you search them up and then for them to have the number printed, you don't print OK afterwards. So that's what I got confused on. So everything else was correct. So that's the solution. Send that solution to the server, and we'll open the model solution in the browser. And there we go. So okay, they divided this into functions, which I guess is fine. I mean, that's not really right. So we're not asked to write any functions. So the fact that they did write functions, I guess, is okay. But I mean, that's that's the solution. I mean, it's a creative way, right, to divide up the tasks, to do it this way, right? So you have a function here for adding names, a function for searching up names, and then they write the main function. So maybe, again, I don't know when the solution was submitted on their end, so this could be probably one of the older versions. Right, so So yeah, that's one thing is I'm surprised that they did that way, but because it doesn't tell you. So this could have been from an older version where they did tell you to write functions. But yeah, you don't need to. This is again one of those things I talk about in programming. There's 100 ways to do the exact same thing. Um, so you can do it this way. If you want to keep in tune with the functions, you can also write it with an add person function and a search function. Actually, since phonebook 2 builds on phonebook 1, we'll just copy this and paste it here. So now it says in this one, so we'll do the function approach in this one. By an improved version, each entry should now accommodate multiple phone numbers. So we'll define add person, takes in a name and a number. Phone book name is equal to number, like that. If name in phone book, or did they return? No, they don't return anything. They just print the name. So we just do print phone book name, and then else print no number. So we should probably pass the phone book so it has access to it. Name string, number also string, like that. If name in phone book, do that. Name is equal to input name, number is equal to input number, like that, like that. So we should prompt for the name also in the lookup instead of providing it. So name is equal to input name, like that. If name in phone book, print the name, and then here we'll have a while true loop that will handle the rest. So here we'll define the phone book inside the while true loop, like that. Then if option 1, we'll call the lookup function and pass the phone book. Then if option 2, we'll look up the add person function and pass the phone book as well. So now what we need to do, in fact, we can just test this to see if it works. So if I do add Emily and 040234567 Emily. Okay, Emily, no number. Interesting. Is it because each time this runs, it gets a new instance of phone book? So what happens if we define phone book outside the while loop. Run it that way. So here, if we add Emily, then we look her up. There we go. Right. So the phone book had to be defined outside of the loop. Okay. So now our code works. The only thing we're missing is this here needed to print OK, like that. Pretty sure. Is that what they did? Yeah. Print OK. So now the application should work otherwise exactly above this. All numbers attached to the name should be printed. So now when we save the numbers, they need to be lists. Right? So numbers need to be lists. Okay, so because it wants us to store lists, it wants us to store numbers now. Okay, so essentially what it wants us to do is, originally we were supposed to store one number per user. But now it wants us to store multiple numbers per user, right? So which means that this needs to be, instead of doing this, we need to use lists. So we need to do if name in phone book, then phone book and name is, I'm sorry, we do phone book and name that append number. Else, which will be just the initialization, will be phone book name is equal to list with number passed to it, and then we print OK. So now this will let us add multiple multiple numbers per name. And now we need to update this because when we do look up a person that has multiple numbers, then it needs to be printed out like this. Currently, what it would do is it will print out something like this, right? It would be like this. So it would be 040, 1, 2, 3, 4, 5, right? Then it will do 040, 1, 2, whatever the other number is, right? But we want him to print individual numbers instead of printing the whole list like that. So we need to do if name in phone book, then for number in phone book name, then print the number. So now this would print out each number individually on one line. Otherwise, it will print no number. So I think this should be the solution. So let me clear this out. Let's run the code. So let's use the examples that they give us here. First, we add Peter, and this is his number. Then we add Emily. So we'll add Peter. That's his number. Then we'll add Emily. That's her number. Then we look up Peter and press his number like that. Then we look up Mary. We should print no number, and it does, just the same as over here. Then we add to Peter this number. So we add Peter, and we add that number. See, it went through, said okay, because we can now add multiple numbers per user. And now when we look up Peter, it should print both numbers. So let's look up Peter, and there we go. It prints both numbers. So that's that. I think now we can quit. Can collapse this down a little bit, and that should be the solution for this exercise. So let's run the tests, and we pass. Send that solution to the server, and we can take a look at the model solution. And yep, so when they look up, they check if the name is in the phone book, and if it is, loop through that key or the values in this key and print out those values. Otherwise, print no number. Then the same thing here. If they check if name not in persons, then they added that name with an empty list, and then they appended. But what we did here was we checked if the person is in the phone book, then append their number. Otherwise, create a new person and have the list contain only their first number. And then they have a main function here that has a loop that calls the different functions. So yeah, that's that. We didn't need to write functions in here, but we did for the sake of keeping up with the formats that we've learned so far. Um, again, we didn't, again, because we're not instructed to, right? We didn't have to do the whole, we didn't have to put this code in the if name is equal to main block. So yeah, other than that, that is the solution for this exercise. And I think that's where we're going to end this video. We're about an hour in. Refresh here, make sure we got credit. So we made it just about a little over 50%. I think we're about 60% done with section 3. When we come back in the next video, we're going to continue reading the rest of the material, and we'll do the remaining 4 exercises. So hopefully we'll be able to do that in the next video in under an hour or up to an hour. So stay tuned for that. This is the most amount of videos I've made in a week in a very long time. For the past couple of weeks, I've been putting out 1 or 2 videos. So I'm trying to get back into the swing of things, making multiple videos a week so we can get through these contents pretty quickly. Summer's almost over, which is crazy to say, which is crazy. It feels like summer just started. We just had July 4th, and it's about to be mid-July in like 4 days, right? So the months are going by, the days are going by quick, the weeks are going by pretty quick, the months are going by pretty quick. So we still have quite a bit to cover. We have 2 chapters and like 30 exercises to cover. So we're almost at the end. Thank you to those who have been following along in the videos. I appreciate it. Make sure you go check out that video that I was talking about that asks for you guys' feedback on how I should structure the content moving forward. I've gotten some feedback so far, and I appreciate the guys that did respond. But yeah, I just wanted to get a couple more people to respond as well to let me know what they would prefer what we do moving forward. If you guys are happy with this format, then I'm happy to keep doing it, right? I'm happy to just read the content on the screen, walk through examples, and do the exercises on video, all in one videos in one sitting. Or if you guys would just prefer that the videos be split into just doing exercises on videos, no content reading, no explanations of any other materials, right? With the expectation be that you would have done the readings yourself, you would have done any extra research that you need to do yourself, then we could do it that way, right? The videos will be a hell of a lot shorter. But I enjoy doing the long form videos and just to share my knowledge and to help people out as much as I possibly can. So yeah, let me know. So I'll link that video in the description below. Solutions that we covered in this video will also be uploaded to the GitHub repository. The link will also be in the description. Please go give that repository a like if you have a GitHub account. It means the world to me. I appreciate the support. Please give these videos a like, subscribe if you haven't. Your support means so much, and I'm so happy that I get to help out so many people. And just to make any sort of impact has been such a rewarding experience for me. So yeah, thank you guys so much for all of the support and feedback. So I'll see you guys in the next video, which will finish section 3, which will leave us with only one more section, which is tuple. So we'll learn a new data structure, data type in Python in the remaining section. So yeah, I'll see you guys in the next video.